So then onto our next topic, going from a script to a project. So in particular, so when we have a little script, there's a bunch of steps that we want to perform in order to get to a proper project. One of the first things when your script goes is that you would like to organize your files more into packages and modules. And that's something, all of these steps I'm going to show you today. Then secondly, we would like to add documentation, and with that, ideally, online and offline documentation, so that we can make it available to other people. Maybe even a project website with some information about our project. Then something that is really important is how to handle errors. And that's something that we haven't really touched upon as part of the course, so I go a little bit on detail on that. Then, of course, we would like to add tests. So this we've learned already, so I just covered quickly. And then also we would like to make the installation more easily for our project. And I'll base, again, we'll use kind of a real test case as part of the lecture, and all the slides all the files are online if you want to just use it as a template for your own project. And so the test case that we will be using is this Monty Hall game that we implemented last time. Remember, it was this web application where you could open one door and then you could win a car if you managed to open the right door. So if you look at the implementation at the moment, it's a fairly simple directory structure of our program. We just have kind of a base directory where everything is contained in. And then I wrote one Python file that just contains the both the web server files, but also the game logic. And then we had a bunch of HTML files. Now, you could argue maybe for such a simple problem, for such a simple program, this might actually just be fine. But just imagine that this would be larger, right? We might actually have maybe an entire web application here. So one of the goals for our mini project here is we want to extend it such that we have both a command line interface and a web interface. Right? So maybe we want to play the game in different ways. And we want to add online and offline documentation and tests and error handling. So let's go through that. The first thing is that we want to split our script into modules and functions. And the first thing that I didn't really like in the initial implementation is that we mixed together the user interface, namely this web programming, and the actual game logic of the Monty Hall game. So as a first step, what I decided to do is to outsource the actual game logic into a separate package. And this is how this package looks like. So a package is nothing else but a directory with Python modules in it. So I created a directory called Monty Hall game. This is the so-called Python package. And then in here, I have a module that contains the game logic, which I also called a Monty Hall game. And then every package also has to have this init file. This is what makes a directory package in Python. And so essentially, I show you the implementation in a second, but first I show you the user interface. So the way I want people to use this package is as following. So first, you import that package. In particular, I implemented a class called Monty Hall game, which implements the game logic. Right? And after importing it, you can create a new game just by instantiating an object of that class. And then in order to play around, you call game.selector. And so this is now a user interface that I just decided might be useful. And I designed it in such a way that it might be useful both for our command line interface, but also for the web interface. Right? So the idea is to create a general module or package that then can be used for various different interfaces. So what does a game typically consist of? We first have to select a door. So I decided on the syntax here, select door, and then as an argument, one provides the door. Then there's a function game.let host open door. So not surprisingly, then we get an integer as a return value here, the number 2, which indicates that the host has opened door number 2. And then I can open then I can choose a door again. So in this case, I decided that I want to stick with door number 1. So I call again game.selectDoor1. And then finally, I call game_openDoor. And then this function returns either true or false, depending if I lose or win. And then finally, I've also implemented this is actually a static method called statistics. And if you call that, then you get an overview, a statistics overview of all the games that have been played. So this is a static method, meaning that I can call it on the instance here, but I could have also called it on Monty Hall game.statistics. Actually, yeah, I need to double check that, but I think that's how I did it. Okay, so let's, and then on top of that, I implemented 2 scripts that use that module. And these 2 scripts are called play Monty Hall CLI.py. This is the command line interface. And then another one called play Monty Hall _web.py. And this is going to be the web interface. And essentially, these 2 scripts are relatively small, and they import this game logic package. Right? So they just make use of the package itself, and they can be really thin. Meaning that if you want to have another interface, you don't have to replicate the game logic. Right? It should be relatively easy. So let's have a look at the implementation of these. So here's my Monty Hall game. Class that implements the game logic. And I won't go through the details here, but essentially what you find here is that you find all the methods that I've just described implemented. So I have this, I have a class variable here that keeps track of all the games that have been played, and how the basically keeps all the numbers that are required to work out what the statistics are about the game. Then here you have the static method. This is a class method that evaluates these statistics and prints them out as a string. Then we have the init function. So all of this is familiar if you were here last week. So we create this unique identifier. So the init function is called when you create a new game, right? So then we decide on a winning door, and I also have a selected door, an open door, and reselected door. And I set them initially as none, and as the game proceeds, we will fill out these, or we will set these variables here. Yeah, and then so this is essentially the same, exactly what we've done last week, just reduced to really the core functionality and not convoluted with the web stuff. So then, as I mentioned, every package needs to have this init function in order to make it a package. And so the init function can actually just be empty, but it's quite common that you import so the init function is automatically called when you import a package. And so a common trick is that you, in the init function, you also import all the variables that are commonly used when you use the package. So in my case here, I import the Monty Hall game class, so that when I type in import package name, I automatically have access to the Monty Hall game class. Okay, and so then we have these 2 binary files. Let's look at the command line interface. So this is now really simple. I have in the first line, I import the game logic. So from Monty Hall game, import Monty Hall game. Right? This is the package that we've just implemented. And then I have a while loop, and inside the while loop, I essentially, this is an infinite sequence of games, so I just create a new game. I ask the user to type in a door in the command line, and then I could just call these module functions. And essentially, I mean, this is now 30 lines of code, so it's really, yeah. And there's nothing complicated here anymore. It's just getting data and sending data to the module and so on. The same thing now works for the web. Essentially, it's now the same with the web interface. So here we have our Flask. So we also import our Flask modules and all these render templates and requests and so on. And then we define these routes exactly the same way. This is essentially the code from last week, just with the game logic extracted and replaced with a module now. OK. Any questions so far with splitting up logic and command line interface? No. Yeah, so that's already quite a good start. So the next step now is to add documentation. And so there are these doc strings, and I hope as part of the exercise you started to always add documentation. And one thing that I want to mention here is that I use a specific style. Typically, when I write my documentation, I use a specific markup style. I've added the link here that defines how you should. It kind of gives you a guideline how you should write the documentation, and I can show you that in a second. So if you look here, so this is. This is very bad contrast. But so one good idea when you write documentation is to, and let's say you document a class, one good idea is always to specify or to give an example how one can use the class. Is that better? No. But so yeah, essentially here I give an example usage on how the class can be used. So I find that often very useful when I read the documentation to just have an example. And then here, for the function, when I define functions or when I document functions, there's a specific markup that I use. Again, this is, yeah, maybe it's actually better if I show it to you here. So here I'm just calling this Monty Hall game question mark, so now I get the documentation in IPython. And so here you see I give some general what this class actually does, but then I also provide some example usage on how one can get started with that class. But then if you look at a function definition, here this is, so the one thing that you should always document is what are the arguments that are being passed into the function, and also what the function returns. And so in this case, I use the special syntax with this with this colon, returns colon, and then afterwards the description of what it returns. In this case, the newly opened door as an integer. And the reason why I use the special syntax is because in a second we will convert this documentation to an online documentation. And with the special markup, our converter can then present these return values in a special way, or even add links between functions and so on and so forth. Yeah, but essentially I went through and added a documentation to all the functions that are public to the user, because these are the ones that are most important. Okay, so once you've documented your code, now it would be really useful to have this documentation also online. And there's a few ways on how you can do it. The first one is called PyDoc. So PyDoc essentially takes a Python file and extracts the information and converts it into a web page, which you then can upload somewhere, for example, to GitHub. And so PyDoc is part of the standard Python package, so you don't need to install anything. And it's really easy to use. So essentially what you need to do is you just type in PyDoc and then the Python file that you want to have the documentation generated. And so this just displays the information, but if you want to convert it into an HTML file, use pydoc -w, Python file. And you can PyDoc even comes with a little web server, so you can even have this HTML file served as a web interface. But let's try this out now with our Monty Hall game. So I'm calling here pydoc -w. So this was the command for generating the HTML file. And then the file that I'm interested in. So it's this Monty Hall game module. So if I try this, I get wrote montyhallgame.html. And then I can open it up. And this is what it looks like. So you see, essentially, you get all the modules that have been imported as part of that file, then all the classes that are contained in that file, and their documentation. So here I have this example usage, and then all the functions that are supplied by that specific class here. So in this case, we only have one class, so the documentation is fairly short. But of course, if you had more functions or classes, then they would all be in here. The second option, and that's so pydoc is something that is maybe quite nice if you just have a single file. And what I actually use in practice is something called Sphinx. So Sphinx is it's a documentation package in Python, and it's a lot more powerful than pydoc. It's also not part of the standard Python, so you actually have to install it, for example, with pip install Sphinx. And so essentially what it does is so Sphinx generates the documentation for your entire Python project. So not just a single file, but for your entire Python project. And you can also add additional actual content and sub. So it's essentially you can have an entire website generated through Sphinx and the code documentation at the same time. Maybe I can give you an example of one of my projects. Yeah, so this is one software project that I worked on, and so this page here is generated with Sphinx. So it's kind of, you can have sliding images and titles, and you can style it. And then if you look here, so here you have kind of various different installations. You don't actually see that this is it. Yeah. So this is just a normal web page essentially. But specifically, it also contains the API. So if I go to developer, no, where is it? Programmer's reference. So here, so this is now, this part here actually describes the different classes that are contained in my software project. And this is all automatically generated from the code. So you see there's a specific class, and then there are these variables defined that go into that into that specific function, your default parameters, and you can add maths stuff and so on. So it's as you can see, it's a lot more powerful. So when you want to start with Sphinx, you essentially go to your project folder and type in Sphinx quick start, and that will set up a /docs folder in your project that contains all the files that are necessary, or some kind of the smallest working example of your documentation. And then you can start adding additional pages, for example, and specify which functions exactly you want to have documented in your project, and so on. So if you look at our so I tried this out. So I typed in Sphinx quick start for our little program, and then we obtained this docs folder. So let's see. Yeah, so then you get a bunch of files, and the only one actually that I edited was this index.rst. So this is the landing page that you get when you visit the Sphinx documentation. And so I just added some basic information about the game. So I just said, welcome to the Monty Hall Games documentation, and I copied the Wikipedia text from Monty Hall Game. And then, so in here, you can see how it's structured. So I have I say, okay, show me the contents. Then I have some installation instructions. Then I specify how you can play the game. And then I have these indices and tables, and this will show all the module documentation for our package. And so a lot of this is now automatically generated. So essentially, once it's set up, let's try this out. If I can now go into the Monty Hall Game 3, let's see. So here now I went into this doc folder that was created with Sphinx, and if I type in make HTML, this now generates the HTML code using the source code. So I essentially want to run this every time I change the source code. I want to also type in make HTML to regenerate the documentation. And then I can type it, and then by default it installs the HTML files in a directory called _build. And if I open this up, then you get our documentation. So now this is essentially this markdown file that I've written before, now rendered in a nice way. You can see the installation instructions, how to start the game. And so most importantly, down here, you have this automatically generated overview of all the modules that we have. And so you can see there's in particular this Monty Hall Game class. And then when I click on it, we'll find again our documentation that we've written with the example usage up here and all the function documented. And so what I mentioned before here is that the special markdown, the special syntax that I used when I wrote the doc strings, this is now important here because you can see that Sphinx actually understands now what part of the documentation refers to the return values or the input values. So in this case here, it highlights it in a special way. But there's various options that you can choose. You can even click here on source, and then you'll see the relevant source code of that function. Yeah?
Could you generate the documentation version? You have a project, you have different versions.
Yeah. Yeah.
When you are using each of the version, you
Yeah.
have access to different documentation.
Yeah.
With like character like this. Could you add this field?
Yeah. So that brings. So of course, this documentation. I store the documentation typically as part of my GitHub repository, and then you can just create a different branch, right? In that different branch, you'll have the documentation of that specific branch, right? So in general, it's a good idea when you have these bigger projects that you store the documentation alongside with your code. So for exactly that reason, you might have different versions, and the documentation should be specific for your version. There's also, so in practice, So what I actually use is something called Read the Docs. It's a website that is just can be used for free, and it's actually really cool. So what they do is that you can give it a link to a GitHub repository, and it will then automatically generate and host the documentation for that GitHub repository. And so the advantage of that is that you don't have to, you have to set it up once, but then essentially whenever you push something to that GitHub repository, Read the Docs will automatically download the updated version, regenerate the documentation, and make it available on the web. So this is what I essentially use for this web page that I've just shown you, this open title farm. This is hosted on Read the Docs. But I don't have to do much, so I just, when I do my development, I just push my changes to my GitHub repository, and then Read the Docs automatically realizes that something has changed, updates the documentation, and hosts it online. And so this also, you can switch between different versions. So here's the latest version, but yeah, you can essentially go back to my development branch, or yeah. Okay, but essentially now after you've, if you decided that you want to have a Sphinx documentation, then you will have a new directory called /doc in your project, and that contains all the Sphinx files that you need. So typically, in my case here, there are just 6 files. Okay. So the next thing that we want to do is we want to handle errors. And so one problem that we have with our script, both actually the web interface, but also the command line interface, is that we don't handle errors at all. So for example, let's try it out. So if I play the command line interface, bin play CLI, so here we go, I can select a door. And so here I can, for example, select -1, right? And the game doesn't even complain. It just lets me open -1 door, or door number 5, or here I can probably type in 6. And then I've lost, right? No big surprise. But so maybe it would be useful to kind of handle these cases a little bit better. And in this case, it actually just ignored it, but it could also crash, right? So which is not good. Yeah, and for that, we need to learn how to handle errors in Python. Okay, and so errors in Python are handled in a special way with a concept called exceptions. And I'm sure you've seen these before when you made maybe an implementation mistake. So I show you some examples where you will see an exception. One example is if you try to divide a number by 0. So if I try to execute this code, you'll see that you get a so-called 0 division error. So this is a specific exception that that occurs when you try to divide something by 0. And so you will always get the name of the exception, but you will also get some additional information as a message. In this case, it just says division by 0. Let's try another example. Let's try and open a file that doesn't exist. So here we have this hello.txt. It doesn't actually exist on my file system. So again, you will get an exception. In this case, the exception is called file not found error. And again, you will get a message with more information. In this case, it's no such file or directory hello.txt. So these are kind of one-time exceptions that occur while you're running the program and kind of an invalid command is being executed. Another one is here when you try to access an index of a list that doesn't exist. So let's say you have a list with 12 elements and you're trying to get the 13th element. Then you will get an index error, and the message will be range update index out of range. But interestingly, in Python, also syntax error are just normal exceptions. So if you're making in syntax error, so in this case, I'm missing the brackets around the print statement. And if I try to run this program, this is handled just like all the other cases. In this case, you will get a syntax error and, again, a message detailing more what's wrong. But just to highlight here that errors in Python can be, so in principle, we can handle syntax errors just in the same way as we handle division by zero errors. Okay, so if you come from a different programming language, maybe C, then a typical way of how you would handle errors is to have to special case them and to add if statements. So one example here, if we want to make our division by zero more robust, is by just having an if statement and first check that the number that we are trying to divide with is not zero. And in this case, we can safely execute the division by zero. And then in the other case, we just print out a useful error message. Right? So this is kind of one way how you could handle errors. Now, Python does it, uses a more modern, in a way, more flexible way of handling errors. And these are the so-called exceptions. And so essentially, whenever something goes wrong, Python raises an exception. And you as a programmer, you can handle these exceptions if you want, or you can also just ignore them if you want, and then they will be passed on to the next higher function in the stack. Or if you're in your main program and an exception is raised which you're not handling, then the program will just crash. This is what we've seen at the beginning. Now, if you want to handle an exception, this is how you do it. You wrap your code into a try block. So all the dangerous code will now go into the section here. You start try colon and then the code where an exception might occur. And then following, you can catch certain exceptions and handle them. So you can have one except statement, and so here you can actually specify the type of exception that you want to handle. I'll show you that in an example. So essentially, you have an except statement, and then in the except statement, you write the code that should be executed what happens if an exception occurs. So essentially, this is pretty much the same as up here. Python will try to execute this code up here, and if everything goes fine, then it will just continue. But if an exception occurs, then it will go into this code section here, and it will execute that one. And so you can even specify more precisely which exceptions you want to catch. So by adding the name of the exception here before the colon, you can say, OK, if that exception occurs, then execute this piece of code. And then you can specify a different type of exception here which should be called if that exception occurs. Right? You can differentiate between the different errors that are happening. Let's look at a simple example. So here we have our division by zero error. And now I've wrapped the dangerous part of the code, which is the division by zero, into a try statement. And I just use except colon with an error message here to handle the exception. So now if I execute this with, well, let's first try it with x equals 1. You see that, well, we should maybe, let's print the result as well. Let me see what's going on. OK, so you see that we get the answer 1.0, which is 1 over 1. So that worked just fine. Now if you try 0, now you get so the exception was raised, so we execute this part down here. And we get the message divided by 0. Let's continue anyway. So the code just continues running now. But so the interesting part here is now we can also, this will catch any type of exceptions. So note that I try to convert the variable x to a float. So if I add a string here with 2.0, this will actually still work because I'm doing this float conversion. But now if I try to use x equals a, then I will get I think it's a conversion exception or something like this. But it's certainly not a division by 0 exception that is being raised here, because the command that fails is now the highlighted one here, where we're trying to convert the a string to a float, which doesn't make sense. But nevertheless, because we haven't specified the exception here, which means that we're just catching any type of exceptions, we'll just get the message divided by 0. Let's continue anyway. Right? So this is not a very fine-grained way of handling errors, but at least it's now a very robust program. Right? So sometimes it's also useful to show, so here I had to kind of guess what the error is, divided by 0, so I hard-coded it. But as I mentioned before, you can actually, every exception comes with an additional message, and we can get access to that message. So then specifically, we can, if you use this syntax exception SE, then this object E here is available in the except statements, and we can print it out. And this E object converted to a string is the error message that we are looking for. So if I run this code here, well, you get now this divided by 0, which is still just the hard-coded text. But now we have the error message is, more precisely now, right, is now could not convert string to float. So now you see we get the actual error that is going on. It's the conversion from a string to a float. Okay. Maybe we should, are there any questions? No. Then let's start again in 15 minutes.